So you know you're at a developer meetup when you start with the presentation and all you've got on the screen are a terminal and text editor. It's a lot better than slides, let me tell you. All right. So how many of you have actually committed code to a Bitcoin wallet? Wow. Nobody, huh? Fantastic. One.
Yeah.
Cool. Which one?
Bitcoin J.
Okay. Bitcoin J is fantastic. Mike's actually an advisor for our company. Yeah. All right. So we forked Electrum just to be able to give people a good reference implementation that they can hack with and they can use to build applications. So it works the same way that Electrum normally works, which is written in Python. It's one of those wallets where it's split between the client and the server. The server, all it does is it runs a Bitcoin node, and then the client does all the key management. And so it's really, somewhat usable for desktop use, and it runs on the server just fine. There are people who are running Electrum as their hot wallet for wallets that do, 1,000 transactions a day, 2,000 transactions a day, which in fintech is not a lot, but in Bitcoin is a huge amount. Bitcoin only has maybe 30, 40,000 transactions a day total. I think caps out at we've never seen a day with more than 69,000 transactions. What we did to Electrum is we somewhat improved their BIP32 support to do hierarchical deterministic wallets, and we also took their Multisig support and we tied it to their BIP32 support. So you can do entire accounts, which are relationships between 3 extended public keys. So how HT wallets work is you start with a core secret that you put in mnemonics, and it looks like this. And you derive from... I probably can't. How's that? That's true. How's that?
It's still small.
Still small? We can
It's
go
better.
Yeah.
There we go. That'll do. Okay, so this is the mnemonic for the seed. All of the Bitcoin addresses in here are derived mathematically from that. You can create sub-accounts. And what we did was we took the sub-account infrastructure and we applied a multi-sig scheme to the entire sub-account, where you just link 3 sub-accounts to 3 different wallets, and you step down at address number 1, address number 2, address number 3 in lockstep. So I'm going to do this as if this is running on a server, like Coinbase style, where you used to just be holding everybody's Bitcoin and providing a user interface through the web, and it was all pooled. We're going to show how you can use HTM wallets to segregate those out into user funds and to integrate with a third party to keep you from walking away with it, intentionally or accidentally. I call this don't get doxxed. All right.
So you're in the process of generating that kind of master level wallet then?
So what I'm doing here is this master level wallet for the local wallet's already been created. It's got a seed, it's got a master public key, and it's got its first account.
It's got like 5 or 6 addresses associated with it?
Well, you can create as many addresses as you need to within it.
Okay.
You could have
Those ones
10,
are the
yeah, you could have 10,000 derivative addresses in the same account. So generally, the best practice is every time an address receives some Bitcoin, you archive it and you move on to the next one.
So this makes, you're making parallel trees. You're starting with 3 separate.
Yeah, so I'm doing here's a master wallet, and I'm going to do one branch from the master wallet per user.
Yeah.
And then that will further branch into as many addresses as that user needs.
And the master wallet was built based on that kind of long mnemonic secret?
Yeah. And so that mnemonic secret is the core secret for your signing server.
Right, and that's the hierarchical deterministic tree.
That's right.
But
So
you're saying you're making this instance because this is like a multi-sig thing, so you do 3 separate.
So I'll show you for the first account. Hey Tariq,
Yes.
what's your phone number?
646
646
479
479
60
60
98.
90. So it's asking here to provide a third key. So there's the local key, there's the key it's going to get from our server, and then it takes as a parameter a third key. So we're just going to take this one that I created here. If you're using this service, if you're using this software to use our service to do custody of somebody else's coin in the back of your web app, then we actually suggest for this third key, what you do is you stash it with an attorney. So it'll create 2 or 3 wallets, but because you've got one key and we've got one key and we both have operational integration, it'll be in effect 2 of 2. The reason you're stashing this third key with an attorney is so that someone responsible will have it if one of us go out of business. Yeah, like if your CTO gets hit by a bus. And this is all, you can do this all via the command line too. I'm just using the UX to go fast. So Tariq's phone should ring any second because the service tried to spend his money and didn't have permission to spend that much. So our service, instead of checking back with your app, our service says, no, we got to talk to Tariq first. We think you're trying to steal his money.
Somebody's trying to spend 10 11 BTC. So accept and press 1. If you suspect your wallet was confirmed.
We're done. Not going to work. So what do you do in this situation if this is happening too often? Maybe our app broke, or maybe we're offline, or whatever, right? If all of your stuff's not getting authorized, or if things or big payments that you need to do aren't being authorized, that's when you go to our friendly attorney that stored the third key. And you throw your copy of the wallet into recovery mode. And you can actually create partially signed transactions as a file. And we're working with BitPay to standardize the data set that they use for partially signed transactions for Copay with what we're building into all of our wallet partners. So ideally, every multisig wallet at some point relatively soon should be able to sign any transaction it's a party to, regardless of what wallet generated the transaction. We're not there yet. We hope to be there in a few months. So we're just going to put this on desktop. And then you take the seed for the other wallet. Restore from seed. So you'll notice this wallet knows nothing about the transactions because you just restored it from seed. It doesn't have any of the multisig relationships. It's only got the local wallet. But if you load the transaction, the partially signed one, and click sign, it actually figures out how to sign it, and then it learns the details of the transaction. It still doesn't know the inputs, but it knows that it could accurately sign. And then you can broadcast to the blockchain, and I have my money back. So what we've created is a signing service that can participate in partially signed transactions that can be slaved to users through out-of-band things like email, phone calls, Google OTP, text messages, so that when you use us, we don't authorize transactions because we believe they're good for you. We authorize transactions because we believe they're good for the users. This can be incredibly important if you're afraid of holding other people's money, which if you work in Bitcoin, you should be afraid of holding other people's money. It's just that simple. Bitcoin is money enough that if you lose it for someone else and they sue you, not only will you have to give them back, but if you can't, you may go to jail. Well, the IRS may have to prove that you stole
But
it.
if you control their Bitcoin, the IRS says you're responsible for it. There's a whole different bracket.
Yeah, there's all sorts of stuff. There are consumer protection laws related to holding things of monetary value for other people. There are money transmission laws in every state related to holding money for other people. There are tax implications, especially around reporting. If you provide financial services to other people and they make income and you know that, then you may be obligated to call the IRS. Speak to your friendly attorney. If you don't have one, you should call Dax Hansen at Perkins Coie. But holding other people's money can be very dangerous. Using a service like this allows you to create an account where you participate in a scheme that holds people's money, but you're not unilaterally holding it. We're holding it together in the context of a contract that the user probably entered into, where we each have our defined roles, and each of us are responsible for stopping the other should they step out of the defined roles. Moves Bitcoin, doing Bitcoin with multi-party multisig, moves it out of banking law, which is primarily criminal in nature, back into contract law, which is primarily civil in nature, where arguably it belongs. Also, when you do this multi-party multisig, let me get back to that other wallet we were using, Bitcoin DevTop. It's easy to segregate the funds per user. So you don't have to rely on your database to keep accurate balances. You don't have to attest to balances. The blockchain's tracking it for you. And will attest to each account based on the information you gave us for account configuration. So you use a system like this, nobody can ever claim you misaccounted for their money. Whereas if you want to claim that about Coinbase, it's going to be a lot easier. Or about Bitstamp, or about trading. Because in all of those cases, the Bitcoin's kept pooled, the accounts are kept in a database, and if a user claims that a particular Bitcoin transaction in the blockchain was a deposit into your service, and you disagree with them, it's going to be he said, she said, all lawsuit long. Whereas you configure your accounts like this, all of the accounts, all the addresses in the account will be derivative. User claims there was an address outside of it. We say impossible. We can show you the source code for how the application's written. And it's all tracked, segregated, each fund separate. Also, because you can manually countersign the partially signed transactions with a third key or any arbitrary MFN if there are other keys, then it's very, very simple if we're down to still recover your systems and recover user funds. You only rely on us for uptime so long as you continue to want to use us. If you want to get out, it's not that hard. And you can countersign a sweep transaction that takes as an input all of these transactions. Or if that's too big of a transaction, you can countersign a series of them. But transactions can come out of the wallet from any account. Anyway, so Electrum HTM, it's a fork of Electrum that does multisig well, that does BIP32 well, can be manipulated from a user interface or from the command line, and is easy to use to build your apps. We also want to integrate with all of your wallets. Anybody who builds a wallet who would rather have it be multisig and rather have it be multi-party, we'd love to integrate our service. We'd love to pay you if you get a lot of users. And even if you don't, we'd like to make sure you handle the same standards so your wallet can be compatible with our wallet, can be compatible with BitPay's wallet, et cetera, et cetera.
A quick question. Apologies for the interruption. The Coinbase and Bitstamp example, aren't those pooled funds necessary because the transactions or once you deposit your stuff into Coinbase, are really happening off blockchain on the systems or the blockchain systems of these private companies. So therefore, there is really no way to.
So there's a lot of discussion right now about auditing exchanges, and so I ran an exchange, and this was reconciliation on a Bitcoin exchange is the biggest pain in the ass you're ever going to see, because you have to take the actual log files from your hot wallet, and you've got to reconcile them with your log files from your database, which are going to be a completely different format. And you've got to make sure that every deposit tracks with your hot wallet, tracks up with the deposit in your database, and every withdrawal in your hot wallet tracks up with the withdrawal in your database. And you've got to make sure that all of your other transactions that don't correspond with the wallet or withdrawal had double entry bookkeeping and zero out. That reconciliation process is something that at TradeHill it took us months to develop in terms of how to do it well and good tools to do that and things like that. And I doubt to the end of it that our bookkeeping firm actually knew what we were doing. I think for the most part, they were just looking for that everything totaled to zero at the bottom, and then they trusted us after that. If we had to pay for an actual audit from a big financial house, I would have expected that to take months and cost hundreds of thousands of dollars. But the Bitcoin blockchain is by its very nature must use triple entry accounting.
Every 10 minutes.
So every wallet keeps its own books on the payor and the payee side, and the blockchain keeps an independent set of books that's a copy of every wallet everywhere netted out.
Yes. With the audit, how tough is it to deal with the fact that it's 24/7 trading? I mean, without stopping it, did that add quite a bit of complexity to it, or is that just an afterthought?
Well, in terms of balancing dollar and Bitcoin balances themselves, all that really added was more transactions to audit. But in terms of calculating cost basis and giving people brokerage style statements, which by the way, we're the only exchange to ever have done that, ever. And I'd be surprised if another one does it anytime soon. But yeah, when you're calculating cost bases and profits and stuff like that, 24-hour trading is a real pain in the ass because you have to determine whether or not someone making a trading profit, and you have to have an idea of what baseline and idea of what Bitcoin is worth at any given time and things like that. CoinDesk makes it a little bit easier because they publish closing prices, but it's all bullshit. It's all so difficult. What we can do with this though, because the blockchain will provide a third ledger that's being constantly audited every 10 minutes by the mining network, is if you settle trades on-chain instead of settling them off-chain, then you know that they net to zero. Because if they don't, either the transactions get rejected or you're just paying the miners. So it makes auditing something that automatically happens on a software basis that's easily verifiable and easily netted to zero, at least on the Bitcoin side. It doesn't help you account much on the dollar side, but that's why I trade always segregated dollar balances my user too.
But settlements can't happen in real time. They have to happen.
Well, it depends on your transaction volume. If you're like a local Bitcoins or something, and your transaction volume is in terms of hundreds or thousands of transactions an hour, then that's not actually that bad, and you can just spit those out into the network, and propagation time is only 3 or 4 seconds, and that's good enough for trading purposes, especially since you're holding people's dollars, so you can roll back trades, and you and us are the only ones countersigning. So where does the double send attempt come from? So in that case, you can settle the blockchain in real time. And who cares if it takes time to get into the blocks? You and us are the only co-signers for the transactions anyway. We can trust each other. If, on the other hand, you're a Bitstamp and you're doing hundreds of transactions a minute because people are bot trading against your exchange, then you're probably not going to want to settle in real time. In that scenario, we're perfectly willing to do batch settlement, where you provide us with insight into your matching engine, and you batch up your trades, and every 8 hours or every 12 hours or every day, we look at the batch, we net it out against our feeds from your transaction matching, and if you gave us a batch that actually reflects trading, then we'll countersign the whole thing and we'll post it to the blockchain huge. And there you've got every input to the batch is a net seller, and then the outputs are change, net buyers, our fee, and your fee. So if you have, I'd say the magic number is if you have more than maybe 10 transactions a minute, you're probably going to want to batch them.
What exchange did you say you have?
So
What did you say the name of it is?
So I co-founded a company called Trado with Jared Kenna. It was the second company called Trado. We were an exchange for accredited investors. We had, I'd say, 83 or so active clients. Our average trade was over $200,000. We were the place BitPay sold all of their American Bitcoin. We were the place Coinbase bought most of their American Bitcoin. We were, most of our clients were venture capitalists, hedge funds, and Silicon Valley billionaires on the buy side. And on the sell side, it was BitPay, the major mining pools, and the major mining manufacturers. Interesting at Trado, and what informed the creation of Cryptocorp is at one point we were holding 100,000 of other people's coins or so, valued at about $1,000 each. So at some point, if you had grabbed like me and one other guy and put us in a warehouse and hit us with a wrench over and over and over again, you could have eventually stolen $100 million. And that's the problem with holding other people's Bitcoin in a nutshell. It doesn't matter how trustworthy you are. It matters how trustworthy your organization is. And I don't care if you raise $50 million, you're not going to build Fort Knox. Fort Knox costs a lot more than $50 million. Cold storage is not a reliable way to secure a large amount of Bitcoin. It just isn't. So Bitcoin, what you're used to in Bitcoin, normal Bitcoin addresses when they start with a 1. The address is created by hashing the public key and putting a 1 in front. And so when you send money to that address, to be able to respend that money, what you have to prove to the Bitcoin network is that you're in control of the public key that hashes to that address. So when you publish the redemption, what you're publishing is a description of which inputs you want to select, a description of the outputs of where you're sending the money, and then you sign that whole thing with a public key, and you include the public key along with the transaction. And the miner, well, yeah, with the private key, with the key pair. And you include the public key that's part of that key pair along with the transaction. And the miner, before they decide to include the transaction in the block to take the transaction fee, looks at the inputs to make sure they haven't already been spent. And then they look at the public key to make sure it hashes to the address. And then they look at the outputs to make sure they're real Bitcoin addresses. And if all of that checks out, then they put the transaction in their block and they get to keep the mining fee. Multisig addresses are not generated from a simple key pair. The technology is called pay-to-script hash. And the way you create the address is you write a script that has to be followed to respend money deposited in that address. The most common script is called M of N. There are this many keys that can sign transactions coming out, and you need a quorum of this lesser number of keys, or lesser or equal to number of keys to sign a transaction. So very popular is what we did here, which is 2 of 3. These 3 public keys are capable of signing an output, and you need at least 2 of them to actually sign to make a valid transaction. And that script that defines both the rule set and lists the public keys that participate in that rule set, you take that entire script and you make a hash of that, and you throw a 3 in front, and that's how you get a multisig address. So the address itself isn't actually referring to a key pair. The address is referring to a script that lists a bunch of keys. And so when you deposit money in that address, if you want to respend that money, what you do is you provide that entire redemption script, the rule set and what public keys are involved in that address. And then you provide the inputs that you want to spend and the outputs that you want to send to. And then you have to sign it with a quorum of those keys. And then that whole package, which can be a fairly large file, that it lists the public keys, it lists the rule set, it lists the inputs, it lists the outputs, it lists the transaction fee, and it lists the signatures from the quorum of those keys.
So
That whole batch is a transaction. And the mining network interprets the script and checks the signatures as part of their verification that the transaction is valid before they include it.
So the wallet is essentially managing kind of creation of those different addresses, and then the
That's right.
and then the kind of collection of all them from the individual parties until it's a complete thing that
This-
you can put on the blockchain.
This process right here, when it listed out those addresses, what was happening here is this wallet was creating a redemption script for each address, and then involving an iterative key from the seeds for all three of those keychains,
So,
and then creating a multisig address from that.
so the addresses that start with a 3, those are in the blockchain.
Yeah.
And that's a hash of the script.
Yeah, the addresses that start with a 3 are a hash of the script that describes what you need to do to respend.
But the wallet itself, I guess the code has to be. Somebody could compromise the code and just kind of have all the inputs.
So
to the
this
transaction.
wallet right here is only managing one of those 3 keys. It's got one full set of private and public keys, and then it's got 2 extended public keys that can be used to derivatively create public keys, but not private keys. So once these addresses have been created, compromising funds that have been deposited into them, it's not enough to just compromise this wallet, because this wallet can only provide one out of the required 2 signatures.
But I think, are you getting at the point at which you generate, the generation step is compromisable. Because there's a point at which you generate them and you have all the information at once.
That's right. Which
So-
is one of the things that makes us different than most of our competition, is we require you to do the generation locally, and we also do it locally. So for the script hash generation, the addresses you generate happen on your servers. We generate the same set of addresses on our servers, and if we're not involved in a transaction, the user's not getting communication from us. So you can describe in your fact, because you're working with us, what they should expect to see from us. And an attacker who compromises generation of your system, if he hasn't compromised our system, the users aren't going to get the UX they're expecting, and we're going to find out pretty fast.
I guess what I'm trying to figure out is, even outside the kind of implementation, if I said, hey, let's create a multi-sig wallet together, then I think the general theory behind it is I kind of have my secret, you have your secret, and they have to both be there to
That's
unlock it, right? So if we just say, go create a wallet,
The secrets never need to be present on the same computer at the same time, because you only have to communicate the public keys to create the
Yeah.
wallet.
so I'm kind of step through the process here. You've created something with that kind of long sentence, and that is just the kind of seed.
That's the seed for the private keys that are resident in this wallet.
And then
And
one
then
party
there's-
goes off and does something secret, and the other party goes off and does something secret, and somehow those come together to
So
create the wallet.
my server's already done something secret.
Okay.
This did something secret during wallet creation when it created those seeds.
Mhm.
We exchange the public sides of those secrets, but not the private sides. And since we both do the generation of the multi-sig addresses locally, we can compare addresses that we created.
Okay. So I guess, what I was missing was when you were doing this, your server was off creating its own secret, and you were the only kind of human party involved.
That's right. So there were 3 secrets involved. One secret was already in this text file. One secret was created locally on this wallet when we created the wallet. And the 3rd secret was created on my server outside of the control of this computer.
Anything more than 3.
Yeah, there's no theoretical maximum, but the guys at BitPay have been trying to do as many M events as they can, and they found the mining network processes transactions that are only so large, and their whole redeem script has to be included with transactions, including all the public keys. So the most they've ever been able to get it to process is 5 of 7.
Just because
7 or 507 points.
No, where M is 5 and N is 7.
just because the transaction is getting too big. And they're
The
not-
transaction is getting too big for the mining network to read.
How big of fees were they putting attached to those?
As big as they could. Given unlimited fees, they couldn't get the mining network to relay transactions larger than that.
What's wrong with the miners?
Well, no, I mean, it's like how somebody uses it.
So we really think about 2 different use cases. Use case number 1, instead of having a hot wallet, you have your own signing service, and you use us as a policy authorizer to get you out of holding money, right? Because we don't work for you, we work for the users. And so we will stop you from stealing your users' money. And you can tell the government that, and you can tell your users that. That's one use case. The other use case is If the user's got a local wallet, we can integrate with their local wallet, their version of Electrum, their version of Multibit, their version of blockchain. And we can stop someone who's compromised their computer from stealing the money. And so, in general, what we want to do is we want to end the practice of holding other people's money in hot and cold wallets, ecosystem-wide. We want to end the threat of malware in your local machine as a way to steal Bitcoin. And we want to dramatically reduce people who obtain Bitcoin by fraud.
Are there any cases for like how you could reach your local, like you with 2 or 3 and two people like lost their keys and now?
Generally in Bitcoin, losing keys loses access to funds.
Right.
We don't solve that problem, but we do make it a little bit better.
Who can solve that problem for you?
That's right. There is no way to solve that problem without holding somebody else's money. Yeah, we have an API, and how it works is you structure the transaction locally in your wallet, and let me see if I can go back to the transaction we spent up here. And you provide us with the transaction that you structured. There it is right there. That's the transaction. You provide us with the transaction structure with all the inputs and with your signature. And at that point, we'll authorize it. And we'll interpret, does it break the velocity? Is it going to a known fraudster? Except all of the different things we use to risk score it. And if it's a low risk score, we'll just countersign it and propagate it, and it won't be any slower than propagation normally is. And if it's a medium risk score, then we'll call the user first, or we'll email the user first, or we'll ask for an OTP from the user, or some other way to authorize the user outside of your wallet in a way that you can't circumvent. And if it's a high-risk transaction, we'll tell you to go fuck yourself and we'll call the cops.
Are we recording that?
Let's say if it's
FTP?
2 or 3, and the 2 parties that are not on your server sign a transaction that would meet your high-risk criteria. You send a message saying, hey, we saw something on this multisig, like we didn't control it.
So the contract with the third party is going to vary over time. It depends on what your use case is when you build the application. User wallets, the user actually has both keys, where they'll have the wallet key, and then they'll have the deterministic seed for their recovery key, and they can manually countersign transactions without us, and they're not beholden to us. In that case, all we're really going to do is we're going to notify them, hey, you manually countersigned a transaction. There's nothing we can do to stop it when you do that. If you didn't do that, it's time to freak out. Like, we can't protect you anymore if you didn't do that, right? If it's a use case where you're holding somebody else's coins and we're standing between them and you, and we call that a mediated wallet. In that case, the third party is usually going to be a top 5 law firm. And if they're coordinating without notifying us, then we call the bar.
And you cry.
It's possible to do one of something as well. Like
It-
1 of 5, 1 of 7.
It is, and in that case, I don't know why you would want or need us, because the input that we use to judge to sign a transaction is a proposed partially signed transaction.
No, I just wouldn't go through your. I was just as far as the multi-sig.
Yeah, M can be one.
Well, if you want to know who spent it.
That's right. So you have a wallet that's shared between multiple parties, and everybody has the ability to spend on it, but you want to know who spent it, such as a joint checking account with your wife where you both have debit cards.
So if I'm summarizing you guys to somebody who's not Bitcoin or not technical, it's kind of like we look at transactions, or we monitor your money, and
So-
if there's a suspicious transaction, we try and interrupt it.
That's right. So we do that thing that Visa does, where when you try to spend, we look at the transaction, we either approve it or decline it, and based on how much it bothers us, we may do more work, which is the same thing that Visa does.
Visa makes pretty good business.
What do you do for fraud training data? How do you develop this model in the first place without a lot of-
So what we started with are financial industry best practices, which are remember payees, remember payors, enforce velocity limits, and introduce delays when things are weird. From there, we're going to acquire a data set the old-fashioned way.
Steal it on the hand.
And this is why we're taking the B2B2C approach, where we're not trying to add users one at a time. We're trying to add applications that have users one at a time. So if you've got a Bitcoin wallet that's got more than 100,000 users or so, I will pay you to use our service.
We'll follow up there. How specific are the, I mean, without giving the details, different applications may have different fraud criteria or signals. How much do you expect to go into specifics of those data sets rather than have general fraud?
We expect that there will be different emergent patterns. For consumer wallet use cases, where it really is between us and the consumer and the wallet vendors just shipping code, in those scenarios, we're just going to have to train the model to understand each consumer and to understand each merchant. And so we can see what average behavior is for a consumer, we can see what average behavior is for a merchant, and when somebody tries to spend $30,000 at a gas station, we swoop down. When it comes to application-specific things, for maybe somebody builds Satoshi Dice competitor that holds its house fund with us, or maybe somebody builds a brokerage thing like Coinbase. The BitOasis guys are building something like that, and they presented here a few weeks ago. That might have a different model because they're looking for trade fraud as well as transaction fraud, right? All that stuff, we're just going to have to learn application by application. Some of them, the application will know what they're looking for, and they'll outsource some of that logic to us so their application can't be compromised. And some of it, we're just going to have to watch them. You know, I mean, the same way Visa learns.
Who's your biggest competitor and why are you better than them?
Our biggest competitor is Trusted Coin.
Okay.
They got started before us. They also have a Multisig API that doesn't care what wallet you're using. We are already integrated with the fork of a mass market wallet, and we'll be integrated with mainstream mass market wallets, multiple of them within the next few months. They've been around over a year, and they built their own proprietary wallet and released it as open source. It's the only one they're integrated with. Also, they do transactions they do addresses one at a time with their API. They won't do HD wallets, which can be very limiting for your application. Also, they generate all the redeem scripts server side, so you don't know whether or not you trust them.
What about BitGo?
BitGo only works with their own wallet, not with any other wallets. And they, as far as I know, they don't have any intention to integrate with any wallets. So BitGo is its own ecosystem. It's not going to be part of the general multi-purpose, multi-party, multi-sig ecosystem. It'd be great if they were, but they're just not engaging with those communities. There's another wallet like them called Green Address. It's a multi-sig wallet, but it only works with itself. Honestly, I would love to see BitGo pivot to compete with us. I think it would be better for the ecosystem. When you're dealing with a vendor where they're writing the code that ships to you in a browser at login time, and they're also holding the other key, to me that multisig is a gimmick. They're your counterparty. They're holding your Bitcoin. If they want to lava bit attack you, they will. And just in Bitcoin, what we want to see is getting rid of Bitcoin counterparties. People whose primary business is holding other people's money in Bitcoin have raised about $100 million in venture financing, and they've lost over $1 billion in customer funds. Bitcoin, as an industry, has the worst reputation for counterparties.
What companies raised over, the only companies that have raised mostly up to 160 million have been exchanges. Now,
So-
the biggest exchange that lost the most money was not a venture-backed exchange.
So Gox lost about $500 million. They're the big one.
But they're not a venture-backed exchange.
Bitfloor lost 30,000 points.
Touche. That's still less than $1 billion.
InstaWallet lost 86,000 coins.
True. But still
Silk Road lost 120,000 coins.
It wasn't a venture-backed.
What's the benchmark?
My point is that as an ecosystem, we have failed,
Yes.
and we are not deserving of
But,
trust.
but because we're not financial management software engineers, nor are we financial management security professionals.
But Bitcoin, because of multi-party, multi-sig, doesn't require us to be. It just requires us to stop thinking we are.
I don't know, but you argue a great point. You're doing data analysis on transactions. You're looking at how people looking at behaviors. I mean, if I didn't know better, you sound very much like a security company, and a really good one.
We feel very much like a security company. And our backgrounds are at security. Like I said, at Trade Hill, we were holding 100,000 of other people's coins worth $1,000 each, and we give them back. We had a database that was doing all of our transaction matching using stored procedures. So our database was literally incapable of saving a balance that didn't happen through the possible business process. We only the stored procedures had write capability. Before Trade Hill, my co-founder Miran, who's the co-founder of both companies, technical co-founder of Trade Hill, and he's my co-founder for Cryptocorp. Before here, he was a security engineer in Google's compliance group. He did cryptography behind their payment gateway for Google Wallet. He also did the tool that authorizes employee access to Gmail and other confidential consumer information. And he did their OFAC compliance tool. So when it comes to the intersection of cryptography, compliance, and security, we're, I'd say, one of the best teams in Bitcoin. We're adding...
Teams like you, I've never heard, I mean, that's a pretty impressive background. We have other teams like you in the industry. With the competitors like BitGo, it doesn't seem to have the security background that you have.
I mean, I know that BitGo has investors from PayPal.
If it works.
Yeah, I mean, maybe they're getting good advice.
Do you foresee a way to sort of roll this into providing some kind of guarantee on the customer side, like limited liability up to $100 worth or something like that?
So we are going to buy insurance against professional liability. So when we make the wrong call on signing a transaction, you'll be able to go to our insurance company, and if you can get a court to agree that our rules say we shouldn't have signed it, but we did anyway, if we broke the contract in signing it, then our insurance company will pay out. If we signed it appropriately according to the contract, you're shit out of luck.
Do you know how does it work for Visa by comparison?
Visa also has something like that, where a Visa makes the wrong decision according to the decisions they're supposed to make. If they deliberately make the wrong decision or something like that, then they're liable and they'll pay out. But if fraud happened honestly, then it's not Visa's problem. So,
I mean, I guess.
But in general, when you have somebody who's processing a transaction who's not holding the money, it's very difficult to hold them liable, assuming they did what they said they were going to do. Even if the transaction resulted in fraud or the transaction resulted in theft, so long as they weren't actively encouraging the fraud or the theft, you're probably not going to find it. That said, if a service wanted to get a rider insurance policy that for the purpose of the users of that application, it protected more than that, then we'd be absolutely happy to talk to the insurance company about what we do and about how we help prevent bad things.
If your user says, hey, calls up and say, my computer's compromised, we got hacked, shut everything down from my side. You have this procedure in place to sort of contact the third-party law firm and then, sort of sweep coins.
Yes. Generally speaking, we would sweep in the instance where the counterparty was compromised, like the other application, or in a circumstance where the other company was being so unreliable that we felt like we were at risk from the user's wrath because our partner was screwing us.
I guess just to go back to the Visa thing, I mean, my assumption, I'm not an expert, but my assumption is that it's sort of a matter of intent. Like if there are transactions that I didn't intend to happen, I'm surprised when I see them, I assume that my liability is limited. I don't know.
So, but that's not Visa providing that guarantee.
And you pay 4%.
That's your issuing bank providing that guarantee, and the agreements that they have with merchant banks requiring them to back it up. I'll give you an example. I've got an Amex card, right? I go to a store, I buy a suit, I swipe my Amex card. I go home, I give the suit to a bum, I take a picture of the bum in the suit. I call Amex, I say, hey Amex, this bum stole my credit card, and I found him the next day wearing a nice new suit. Many things can happen over the next 30 days. And somebody will pay for that suit. But I can promise you who's not going to pay for that suit. Amex.
They're just in processor.
That's right. They're in the middle of entities that could get stuck with that bill. But they are not one of the entities that's going to get stuck with that bill.
So that whole suite thing that you mentioned, I could see that if you're dealing directly with consumers, you're going to probably see that a lot.
So
But I guess you're not.
no,
saying that's really
we
the
won't.
law
We
we're
won't be
seeing
dealing
with
directly with consumers. We'll deal with wallet companies and we'll deal with applications. When we deal with a wallet company, each wallet is going to have its own secret, and there's no need to do a sweep thing like that.
Well, if one of those wallet secrets gets compromised, how
Then
does
we can sweep that individual wallet, but we don't have to coordinate with a law firm to do that. Because in the case where we're dealing with a user and their wallet is a secret, the user had both secrets at account creation. There is no law firm in that case. The reason for a law firm is if we're partnering with somebody for an application that handles third parties' money. So if we're partnering with Coinbase that handles their users' money, or with BitOasis or Bitstamp, in that scenario, we would say, listen, in the average scenario, you're going to propose and we're going to countersign. And that's going to be normal, and that's what we're normally going to do. But we need protection in case you go away, and you need protection in case we go away. So let's have a law firm that we agree in the average month will sign 0 transactions, but will remain with the technical power to countersign one of us in case one of us goes away forever. And these will help sweep the funds for all of the users.
So when it comes, one of the other advantages of multisig is just if I lose my password, I can recover it by talking to the other parties.
So it depends on how you structure the wallet. How we're structuring one-party wallets is we're forcing them to provide us with 2 secrets at wallet creation. The one that's embedded in the wallet, and another one which we're requiring them to allege that they have written down and stored somewhere. We're actually asking them to allege that they've written both down and stored them somewhere. And at this point, if you want to recover your wallet, you can by going back to that secret, and all of the keys that were in your wallet can be derived from that secret.
So it's like an everyday occurrence. Somebody forgets their password, right? So
That's right. And
if
right.
I'm just a user, grandma who created a wallet, and I forget my password, then I could just that's between me and the wallet company
So,
to recover that.
So there's a big difference between wallets and accounts in Bitcoin. And there are a lot of companies that issue accounts that call them wallets that really confuse them. If you're not signing transactions on your local computer in a way that no one you're working with can fake, then you don't have a wallet. Wallets handle keys that sign transactions. That's what wallets do. That's what Electrum does. It's what Multibit does. It's what blockchain does.
So what if I got a Coinbase?
You've got an account
You've got an account.
where you've got an account that's denominated in Bitcoin that they owe you, that they're alleging that they're storing. But you don't have any keys and you can't sign transactions.
Right.
All you can do is say, I want you to send Bitcoin for me to this place. If grandma forgets her password at Coinbase, Coinbase can help her change her password. If grandma forgets her password on blockchain, then what blockchain has to ask for is, grandma, that thing we told you to write down when you created your account, we need that to change your password. Do you still have it?
And don't lose
If I'm
it,
just buying a
because
house, I wanna
we're gonna make
transfer
sure that you write it down
$100,000.
3 times.
Well, it's
I need a
impactful
third
for the
signature
individual
that's
user to
So
know
one
all
of the uses of our API will be having us stand between you and a counterparty like we were talking about for an application. That can be just between you and a counterparty for a single transaction. In which case, you'd have a wallet, and you'd provide in your account configuration the key you put here is the key for the guy who's selling the house,
Right.
right? And so it creates a 2 of 3 wallet where the 3 parties are you, me, and the guy who's selling the house.
Right.
Right? You're buying Tariq's house. You, me, and Tariq.
Sure.
Okay? Then you put the money in.
Yeah.
It goes in there. One sec. Let it finish generating.
Can you time it out so after that 30 days it goes back to you?
You can build whatever policies you want.
Oh, okay.
Yeah. So you put the money in there. When you try to spend from there, We're going to call him, and we're going to say, is the transaction off?
Right.
And he's going to say, yes, the transaction off, and we're going to let you spend the money. Or he's going to say, no, man, he's got to take my house. Give me that money. And
I'm
we
going to
won't
say
buy
he
it.
hasn't signed yet. Don't you dare.
That's right. And if he tries to take the money out, then we call you,
Right.
and we say, do you have a house yet?
So you're going to need double authorization from me. You need to send me money, then you need to release
So
it.
you put the money in,
I
and then
take it
our
back,
and
but
now
I
we
can
work
release
for
it.
we work for the contract and for the money, not
Right.
for you, not for him.
Right.
And so if he tries to withdraw, we ask you. If you
One
try to
second
withdraw, we ask
authorization,
him.
right.
If you guys can't agree, we wait for a judge to tell us what to do.
Or until the contract expires, and I take my money back.
If that's what the contract says.
Okay, good. What about altcoins?
We love altcoins, but what we love most are transactions per day, because that's how we make money. And so when any altcoins have
Okay,
enough
so
transactions
when
per day,
Dogecoin eclipses Bitcoin next month, you'll switch over?
Yeah.
Okay.
Absolutely. Anything that enables something like threshold signing or P2SH or some other technology that enables our business model, once it gets enough transactions per day that we want the money,
Okay. But
We'll
for
support
now, it's Bitcoin.
because Bitcoin is the only
Yeah,
cryptocurrency
and
that
for
does
the
it.
foreseeable future, it's going to stay that way.
You said it, not me.
I know, but I'm guessing.
I'm coin agnostic.
Okay. So the Bitcoin next week.
When you said that you have an application that you are working with, so what are the three keys in that case? For example, with Coinbase, we are working with Coinbase.
So if we were to work with Coinbase, I didn't say we're working with Coinbase. We tell Brian that. If we worked with Coinbase, then what we would probably do is a 3-phase migration. Phase number 1, let's get their hot wallet multisig now, so it doesn't walk away. Right? Let's just impose global velocity loan time. Phase number 2, without changing their UX, let's reorient how their hot wallet works to make it not a pooled hot wallet, but instead a signing oracle that segregates the money by user and signs transactions appropriate to the accounts, right? And that would be stage number 1 if it's a new application. And then stage number 3, stage number 2 if it's a new application, is for advanced users that would like to tie a different wallet to this account. Maybe they've got a copay wallet, or maybe they're working with one of the mass market wallets that we're bringing to market soon. They can throw in that key too. Instead of then being at 2 out of 3 Coinbase us lawyer, it becomes 2 out of 4 Coinbase us lawyer user. And so yeah.
So in that case, it becomes a code of 4. Then
Yeah.
And
And we're the one who's programmatically enforcing policy. So we're the one that everybody should try to work with, because we're the reliable people.
just Coinbase and the other guy can just sign it. You don't need to.
They could. They'd have to develop a method for sharing the partially sent transaction, but presumably it wouldn't be hard.
But you would be able to see after the fact which party.
If we saw Coinbase or another application partner often collaborating with the wallet and cutting us out of the transaction, then we would probably ask them to just still pay us our fees because we're sitting here being available for them, being integrated with their application, running potential liability. So cutting us out of the transaction on an ongoing basis as part of your application is not a good way to build a good partnership and save money on fees. You have to choose. You're either going to save money on fees or you're going to build a good partnership.
Final question?
Can you talk just a little bit about the signatures that start with 3, and then just like you said, the ones that start with 1. are
So
usually
addresses.
1. Yeah. So you can reuse those things for anything else, right? Like they're just for this multi-sig signing, right?
So multi-sig addresses are legitimate Bitcoin addresses, just like the ones that start with
So
1.
you can send money to them.
Yes. In fact, they're not useful until they've received money, just like normal Bitcoin addresses.
Okay.
There's no signing a transaction to respend money that's not there.
So they're interchangeable.
Yeah.
Okay. But they're just created through different.
They're created through a different process,
Okay.
and then they follow a different process to create legitimate transactions to respend what's deposited there.
Okay.
But that's it.
Okay. They're technically through.
They are normal Bitcoin addresses, and you can send money to them.
You can do one of one on pages. You can make a one address into a three address with one key.
That's right.
One.
And then all you're doing is saying fuck you to the miners by giving them bigger transactions.
Can we, Hope you're okay. Are you burning? Awesome question.
I just have one quick question. One of the reasons you might want to hold your customers' money is to create maybe drip payments or micro payments between your users.
Batch settlement.
Right. Oh, so you're saying you do that?
We don't mind doing batch settlement.
Are you guys hiring? Looking for talent?
Absolutely. So if you have done UX for any major financial brand, if you have contributed code into Bitcoin wallets, especially Bitcoin J or Bitcoin JS, if you want to work with the top brands in the industry, want to contribute to top 5 wallets, or if you're building a Bitcoin application that handles money on the server side, all of those are very, very good reasons to call me. We pay very well. We're looking for advisors, we're looking for wallet engineers, and we're looking for UX people.
Thank you. Awesome.